Okay, our objective is to continue reviewing for the probability quiz. Just a reminder that your probability guide, as long as you did your review and are okay with what we do in class today, you should be prepared. Just remember, you have your notes to study from. If you ever want to practice more problems, cover up the review sheet answers and try some of them again. Okay? Do the same thing with the warm-up I gave you today. The warm-up from today that I typed yesterday is just like a random assortment of all the probability problems. That's another good review worksheet, okay? And the book has some more review problems, but they're not, since I added a lot to this, they're not as good as what you already have. The review in the book does not have letter arrangements. It does not have a lot about factorials. So I would use what we have in our notes and anything that I gave you, okay? Any general questions for me about your tests on Monday before we start? Sure? Okay, so your homework over the weekend will be to study. Okay? All right, let's start with the warm-up, and then we'll move on to going over the review sheet. Okay, so number one, I'm not going to write up there. I just need someone to explain in your own words what is the difference between theoretical and experimental probability. Peyton. Good. Good job. So theoretical is what it should be. In theory, what should happen. Experimental is what happens after you perform an experiment. Does anyone remember the fraction or like the little formula that we use for theoretical, or what is the fraction that we use for experimental? Neil, do you remember? Good. I don't know why I was writing that. Yes, good. And experimental? Nope. You can consider it kind of the same thing. Number of what? Do you remember? Peyton? Good. Number of successes over number of, Grace? Good job. So this is another way of explaining it. So experimental, maybe how many tails you get on a coin over how many times you flip that coin. What happens after an experiment? Theoretical, in theory, what happens? Favorable outcomes over total outcomes. Okay, David, 2A, what did you get? Good, 159 over 1,000. Did anyone convert this to a decimal or a percent? You didn't have to. Okay, 15.9% if you did. Remember, decimal fraction or percent for probability, it doesn't matter. Abigail, 2B. Good, 303 over 1,000. Did anyone convert this one? Neil? Good, 30.3%. Again, decimal fraction or percent is okay. Ben, are you checking your answers? Okay, put your calculator down. Okay, Mike, number 3. Good, 4/9. Did anyone change this one to a percent? Grace? Good, 44.4 repeating percent or 0.4 repeating if you had it as a decimal. Okay, Evan, 4A, please. Good. And I did this just to maximize space. That's why I did A, B, C here. Amberly, 4B. Good. 4C, Greta. Good job. Jackie, 5A. Good. 5B, Josh. 5B. What did you have for your factors of 6? Okay. So that's right. What are the odds in favor of getting such a number? So how many factors of 6 are there over, do you know what I mean? Good. So 4 over 2, which reduces to 2 over 1. Okay, Skylar, part C. Good. 2 over 4, which reduces to 1/2. Was everyone able to check the first page, or if you didn't start your warm-up when you should have, did you write in the answers? Do you have something to study from? Okay, Jordan, number 6. Good job. So 9.9 million. Steve, calculator, how many ways are there to arrange the letters? No, too much. David? No? Still too much. Camille? Good. Okay, while I'm on this one real quick. So calculator has 10 letters in it. So 10 factorial over, there's 2 C's, 2 L's, and 2 A's. So you should have done 10 factorial divided by 2 factorial times 2 factorial times 2 fact. Okay. In parentheses. And I don't know how many times I'm going to say this, but you need to make sure this is in parentheses. So when you put in your calculator becomes smart. Remember, you have to tell the calculator what to do. Gio. You think I added what? Oh, I did. Oh, geez. Thanks, guys. I even had Starbucks this morning, and I'm still not writing things correctly. True. Say that again? Okay. Yeah, and that's why I wanted to do this today. One more time. Don't forget those parentheses. Kevin.
If you know what 2 factorial is, what 3 factorial is, we just multiply by
Yep.
that.
Yep.
What I did was 10 factorial divided by 2 times 2.
That's what I did too. That's fine. I usually do that just because it gets to be a pain typing all that in the calculator sometimes. That's fine. Just make sure that you're careful and you're multiplying correctly. Okay, Alexis, number 8. Good. Ben, number 9. 380? Should be 1 over 380. Is that what you meant? Okay. Joseph, number 10. Good job. And I probably should have talked to you about this, but I didn't. 0 factorial is 1, because if you're trying to arrange 0 objects, there's one way to do it, right? There's no way. So how many ways are there to arrange 0 objects? There's no way. So there's one way to do it. No ways. This is something that is in the algebra book. I should have added it into your notes. I forgot about it. But you can use your calculator, and it will tell you 1. What did you say, Abigail? Yeah. Yeah. Okay. Neil, number 11. Good. 1 over 120. Number 12. Evan? Okay. This is one where I multiplied wrong by accident, but Skylar and Mike found my mistake. Gio? Good. 1 over 67,600. And then number 13 is just a problem that I wanted you to find the mistake. So what was wrong with number 13, Abigail? Good. So what should the answer be? Good. So it should be 9. The multiplication counting principle says multiply the number of options together, and that's how many different combinations of outfits that this person has. Camille. 11? Okay, so Miss Wingrove and I, when we go to football games at Penn State, we like to sit there with our friends and hold signs up that spell Lions. I never really did that, did you? Okay, but let's pretend like we did when we went to Penn State football games. So if you and 4 of your friends are holding up posters and they spell Lions, and you're trying to stand in order so you're spelling it correctly, okay? There's one way to arrange us with our friends to spell that correctly. So that's where the 1 comes from. There are 5 factorial ways that we could arrange us and our friends. So maybe Miss Wingrove's over here, maybe some random girls here, maybe I'm here, but we're not spelling it right. We're just standing there just because. So the probability of us standing in the correct spot to spell this correctly is 1 over 120. Okay, and don't do that because once you put an L down for lions, you're done with the L's. Then you have the O to put somewhere. Then you have the N, etc. Make sense? That was a good problem. I didn't know if you guys would. Anyone else have trouble on that? Okay, Ben? On which one? You got 24? But did you read it? It's you and 4 of your friends. So there's a total of 5 people. So you should not be using 4 factorial. You want to do it as favorable over total, Ben. So there's one way to spell the word lions correctly, and then there's 5 factorial ways to arrange all the letters in the word lions. It's factorial because you're arranging letters. Anytime you're arranging something, you should be using factorials. Yeah, that's the answer. What do you mean, what about the other ones? What other letters? Say that again? No, try to explain. The only letters that we're arranging we're not doing Nittany lions, we're just doing lions. Well, okay, but it can't repeat. That's what Camelia was asking. So we have 5 letters for the word lions, right? So the first letter that we're trying to arrange, maybe we're trying to put the L in the right spot. We have 5 spots to put the L, right? So I'm going to put a 5 here. You can put the L anywhere you think it's supposed to go. Maybe we don't know how to spell lions. 5 spots. The second letter, let's say we're trying to put the S or that person that's holding the S in the correct spot next. There's 4 spots that we can put that S in. So the S can go anywhere. I'm going to put a 4 down here. And then the next letter that we try to arrange, there's 3 empty spots in the bleachers to put that person holding that letter. Is this making sense? Times 3. And then the last 2 letters, there's times 2 and then times 1. So there's 5 times 4 times 3 times 2 times 1, which is 5 factorial ways to arrange all the letters in the word lions. What you were saying, Ben, you should have done 1/5 times 1/4 times 1/3 instead of 1/5 times 2/4 times whatever else you had. Okay, you just forgot that there's only 1 spot that L can go. The favorable outcome is 1 because the L has to go here. The I has to go here. You with me? Okay. So favorable over total when it's regular probability, or even if you're arranging something, you want it to be spelled correctly. We don't want to look stupid at the football game, right, and be spelling lions the completely wrong way, which could happen. Okay, anyone else have questions on anything on that warm-up? Positive. This is another good sheet to study from, so hold on to that. Let's turn to your review. We're going to go through these quickly, so I'm just going to go around the room in order. Just tell me what you got. I will write them up here. I'll answer questions, and then we'll start our whiteboard review. All right, Greta, we're going to start with you on number 1. Good. Abigail, number 2. Jordan, number 3. I'm sorry, I'll wait. We're on the review. Steve, number 3, and I'll come back to you, Jordan. Good. 1/182. Jordan, number 4. Good job. Neil, number 5. Good. Number 6, Shane. Good. Shane, you got, I know I gave this to you 2 days ago. You got it done, right? Okay. David, number 7. Good. Number 8, Greta. Good. I'm just going to put fave and then unfave. Number 9, Evan. Good. So this one's flipped. Unfavorable, favorable. Amberly, 10. Nope. So if you sat in class and you rolled a number cube 60 times, okay, you recorded your results of every one. The 2, you landed on a 2 12 times. So you found that the probability of getting a 2 is 1/5. That can't be theoretical because it should be 1/6. So if it's not theoretical, what is it? Yeah, because you were doing an experiment. You recorded your results, or someone did, and that's what you got. So that one should be experimental. The starred one, that doesn't have a number, Grace? Good. X equals 3 desserts. That one used the multiplication counting principle. So you should have done 6 times 2 times X equals 36. In other words, 6 times 2 times what gives you 36? Nathan M., number 11. No? Off a little. Kevin, number 11. Good. Number 12, Peyton. Good. 13, Michelle. Good. Joseph, 14. Say that again. No. Odds against. It should have been unfavorable over favorable. Camelia, what'd you get? Good. 4/1. Joseph, you just had it flipped. You want to do how many for 14 are not greater than 7 over how many are greater than 7. Okay? Okay. Jackie, 15. Good. 48 times. 16, Alexis. Say that again. Good. 1/7. Ben, 17. Good. Or 3/7. That's fine though. Mike, 18. Good. And then reduce it to 4/3. Make sure you simplify everything. Geo, 19.
32.
Good. 32 possible outcomes. It said there to use a tree diagram. That was a pretty big tree diagram, but 32 possible outcomes. Andrew, did you finish or no? Okay, that's fine. Just put it on my desk. All right, number 20. Grace, we're up to you there. 20A. Good job. Drew, 20B. Good. Thanks, Andrew. 20C, Ray. Okay, so based on the problem in C, if the first digit can only be a 1, yes, there's 10,000 or 1,000. But it asks you how many more extensions are possible with the new system if the first of the 4 digits can only be 1. So you need to compare the new with the old. So in other words, that's half right, Ray. But compared to the new and old, how many more extensions are possible? Do you know how to answer that? Kevin? Nope. Camille? Okay, why is it 0? Good. So the old one, Ray, at the very beginning of the problem, there were only 1,000 different options or possibilities for passwords. And then based on what part C says, if this one only has 1,000 and it's the new one, there are not any new extensions available. They have equal possibilities. Okay, that one was a little, the wording was a little weird. Josh, part D. Okay, so you had that. Okay, so it should be part B. B provides more because B has 7,000 options. Okay, Skylar, 21A. Good job. 21B, Steve. It's 1,000, right? Okay, that's okay. Jordan, 21C. Good job. Abigail, 22. Close. Greta, 22. No. Evan, how did you get that? Good. So 1 over 10 times 1 over 10, you get 1 over 100. That one was a little tricky. Okay, questions for me on any of those? Drew? Is it really, really necessary? No, just wait to the end of class. Do that before class or after class, okay? Amberly? It is, okay, so the answer is 8,000. So it's how many, it asks you how many more extensions are possible with the new system if the first 4 digits cannot be 0 or 9. So if the first digit cannot be a 0 or a 9, there's 8,000 possibilities, but you need to look back at the old system. The old system has 1,000 possibilities. So if you take 8,000 minus 1,000, it's 7,000. So there's 7,000 more passwords that could occur or could be available. Greta? Okay, number 22 asks you to find the probability that the spinner stops on a 4 and then on a 10. So that spinner next to 22, the probability of getting a 4 is 1 over 10, because there's 1 4, there's 10 possibilities, times the probability of getting a 10 is 1 out of 10. There's 1 10 and there's 10 possibilities. I mentioned this in our notes a couple days ago. This is really not in your book, but your book throws these problems in. If they ask you for a probability of 2 different numbers and it's separated by and or then, you're just going to multiply the 2 probabilities together. Does that make sense? We're going to get into a lot more detail about this next year. It's a compound event. It's just not in your book. Anyone else? Questions on the review or anything that someone already asked about? Positive. Okay, give me a thumbs up, thumbs middle, thumbs down. How do you feel with the warm-up that we did today, and how do you feel about the review? Mike, thumbs up, thumbs middle, thumbs down. Neil, Ben. Okay, you sure there's not any other questions? For those of you who have your thumbs in the middle, you sure there's not any other questions for me? All right, put everything away except for your calculator and whiteboard and an eraser. Okay, no marker requests. I don't even have any pink ones.
Right there.
Oh. Okay, Kevin. Next time you're not yelling out, okay? Most of the markers are red because when I ordered new ones, they only had them in single colors instead of multiple, but that's okay. So be careful with these markers. A lot of these are new. Make sure you're not pressing too hard. Oh, Greta, I'll come get yours in 1 second. Bless you. Okay, check your marker when you get it. Make sure it works okay. Thank you. This, you guys all have it. Neil. You're fine with the one you have, okay? Doesn't work. Okay, here, put that cap back on. And take that red one. That red one definitely works. Anyone else? Okay, listen again. Please make sure you're not pressing too hard so that the tips go inside the marker, because then we're not going to be able to use it, okay? All right, and then also only math on the whiteboard, so everyone erase. I know that your markers work now, so your board should be cleared.
Works very fast.
After you get an answer, Neil, turn around, please, okay? After you get an answer, hold up the board, okay, so I can check it for you. Just be patient with me so I can quickly check everyone's. Once you get it right, you may erase. If I say fix it, make sure you fix it and then try to hold it back up. I'll try to keep it at a good pace so that if you are trying to fix it but you get stuck, I'll make sure I talk through the problems, okay? Okay, hold on. Okay, first problem. You must create a computer password for North Hills consisting of 4-digit. Any digit can be repeated. How many different passwords can you create? Good job. Awesome. Great job. Good job. Try that again. Good job. Camille, try that again. Good job. Very good. Great job. Very good, David. Greta, try that again. Good job. Very good. Excellent. Awesome. Great job. Excellent. Very good. Awesome. Good job. Drew, try that again. Still try that again. 10 times 10 times 10 times 10. 10 times 10 times 10 times 10. Use your calculator. It's not 1,000. Promise. Good job. Very good. Great job. Much better. You understand that? Okay. Drew, let me see. Okay. You just multiplied wrong. Should be 10,000. You have 1,000. You wrote 1,000 on yours. Oh, I was looking at this. Sorry. Was that your old answer? Oh, sorry. You're good. My fault, Camille. All right. So you should have 10 times 10 times 10 times 10, which is 10,000. Okay, 10,000 different possibilities because you can have repeats. There's 10 digits that we have. Questions on that? Okay, I'm going to go to this one. How many letter arrangements are there in the word Indians? So let's get some North Hills problems in here. How many letter arrangements are there in the word Indians? Don't forget parentheses. Drew, you need to try that again. Don't forget parentheses. I print these from the smart board if you ever make these, so it's like quick for me to check. And I put their answers on, you know, if you don't mind. Yeah. Thank you. Try that again. Great job. Awesome. Excellent. Jackie, try that again. Joseph, try that again. You guys are forgetting parentheses. Awesome. Try that again. Steve, try that again. You're forgetting parentheses. You didn't. Okay. Good job. Evan, try that again. Awesome. Great job. Very good, Abigail. Shane, try that again. Neil, you can't yell out. Hold on. You gotta put your hand up if you have a question. Good job. Very good. Great job, Camille. Drew, awesome. Ray, very good. Excellent. Great job. Awesome. Okay, you gotta raise your hand. You can't yell out. There's a lot of people in here, not just you. Okay?
Yeah.
Still not right.
Don't yell.
Hey, Kevin, mind your own business, please. Good job. Drew, were you holding that back up again? Okay. Josh, try that again. Jackie. Nope, try that again. Okay, I think we need to do another one of these. So, much better. Good. Here was the problem. So, you should have done 7 factorial over 2 factorial times 2 factorial. You need parentheses here. That might have been part of the problem, or some of you probably forgot that there were 2 repeats. 1260 is the answer. I know Ben likes to do it this way, so I wrote this way up as well, in case anyone else likes to write out the factorials. Jackie? I thought you had 2560 on yours. Yeah, I said that one was good. I was probably looking at Drew's. Your first one needed fixed, though. Yeah, your second one was good. Sorry. And next time I'll say your names so you know who I'm talking to. Any questions or comments on this? Okay, I'm going to give you another one of those types, so give me 1 second here. Oh, man, I forgot to put it on here. Okay, we'll come back to it. Let's do this first, then I'll go back to the other one. Okay, so this is a long problem, but I'll read it for you. In the early 1970s, Canada Post started using 6-character postal codes. Each postal code uses 3 letters and 3 digits in an alternating pattern. How many different Canadian postal codes are possible? There may be repeats. They are not case sensitive, which means an uppercase and a lowercase are the same thing. Okay? Ray, great job. Jackie, awesome job. Skylar, awesome. Okay, and I'll go back to another problem like we just did in a little bit. Abigail, that needs fixed. I think you might have multiplied wrong. Awesome, awesome. Nathan, Evan, Kevin, good job. Shane, Evan, great job. David, very good. Grace, excellent job. Gio, excellent job. Neil, very good. Greta, very good. Camille, great job. Neil, very good. Abigail, great job. Peyton, awesome. That's okay. Just figured I'd tell you. You might have multiplied wrong. Josh, try that again. Very good. Awesome. Good job. Amberly, try that again. Amberly, they're alternating, so it goes number, letter, number, letter, number, letter. Or, yeah, number, letter. Try that again. Jordan, it's not case sensitive, which means that an uppercase and a lowercase mean the same thing. That'll be clarified on Monday for you. Good job. Good job, Drew. Okay, on this one, we have 17,576,000. It was 10 times 26, etc., all the way down. Drew? You just type in 10 times 26 times 10 times 26. A quicker way? No. You just have to type them all in. Yeah, you can do exponents. Yeah. Yeah, you can definitely do 26 to the third times 10 to the third. It depends. To me, it's faster just to type it in like that, but whatever's faster for you, it does not matter. Much better. Good. Any questions for me on that one? Okay, let's see. You guys are pretty good with regular probability. So here we go. There's 2 questions to this. Put an A and put a B on your board. Erase all of that, Ben. All math. Okay, part A. Well, actually, here's the problem. A bag contains 8 blue marbles, 6 red marbles, 15 green marbles, and 16 orange marbles. There's a total of 45 marbles to save you some time. It says, part A, a marble is chosen at random from the bag. What is the probability that the marble is red? So part A is, there's 45 total. Part A is, what is the probability that the marble is red? Part B, there's 45 marbles total. Part B, what are the odds in favor of choosing a green marble? So I need both of your answers before you hold it up. Awesome job, you can erase. Joseph, make sure you simplify on the test Monday, but very good. Gio, great job. Make sure you simplify on Monday. Awesome. No, it's not. 6 over 45 needs to be simplified. 3 goes into each of those. Good job. Great job. Yeah, that's the second part. What are the odds in favor of choosing green? It's up there, Josh. You can read it. Ray, very good. Awesome job. Excellent. Very good. You need to simplify A, and B is not right. Great job. Very good. B is not right, and simplify A. Very good. Great job, Camille. Awesome job. Awesome job. Both those need fixed. Awesome. Very good. Great job. Drew, much better. Good. Much better. Evan, you want me to read it again? You got it. 45. Josh, those both need fixed. Okay. Good job. Okay, part A, which is the regular probability, should be 6 over 45, which reduces to 2 over 15. Part B should be 15 over 30, which reduces to 1/2. Questions for me on either of those? Okay, let's go to next one is about animals. All right, a wildlife preserve identifies each animal in the preserve with a 1-digit number and a capital letter. How many animals can the preserve identify? And then it says, how many animals can the preserve identify using a 2-digit number and a capital letter? So there's 2 answers here. How many animals can they identify for part A with a 1-digit number and a capital letter? And then part B, how many animals can they preserve using a 2-digit number and a capital letter? So I should see 2 answers on yours. You can label them as A and B if you want. Good job. Awesome. Very good. Awesome job. Great job. Very good. Check part B. Good job. Camille, try the second part again. Grace, very good. Gio, very good. Awesome job. Excellent. Very good. Try part B. Actually, you're good. I thought your line was a 1. Good job. Very good. Excellent job. Great job. Very good. Try part B again. You're close. I don't know why. You're off a little bit. You just multiplied wrong in part A. Yeah. Okay, part B says, though, so if we identify the animals with 2 digits and a capital letter, so we would have 10 times 10 times 26. So there's 2 different parts, David. The first part is they use a digit and a letter. And then the second part says, well, what if they use 2 digits and a letter? Does that make sense? Okay, it's just 2 different parts. I got this from the book. That might be a little confusing. Try the second part again. Good job. Good job. Awesome. Very good. Second part, Mike, don't do that, please. Second part needs done again, Josh. Very good, much better. You just multiplied wrong. That was something easy to fix. Okay, part A should be 260. Part B should be 2,600. Did I? Oh, maybe it looked like.
I got 67.
What did you multiply for this part?
I did 26.
Gio. Oh, okay. Sorry. My fault. You just read it wrong. 2 digits and 1 letter. Amberly. No, because your digits are from 0 to 9. So the first digit, it doesn't say anything about repeats. So we're assuming that it could be 2 and a 2 and then a B. You know what I mean? If it says something about repeats, then it's going to be, there. You might have a 9. It's going to be different. Sure. Okay. Erase that if you didn't already. What are the odds in favor of choosing a vowel, A-E-I-O-U, from the word elephant? Good job, Grace. Awesome, Ray. Good job, Josh. Good job. Drew, be careful. Never use total with odds. Try that again. Awesome. Good job. Good job. Very good. Very good. Good job. Good job. Awesome. You guys are fast. Good. 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 Good job. Why's your 5 so little? Oh, yeah, you just counted wrong. That's why I had to count them. Good. Very good. And percent's fine. Remember that. Never use total for odds. Good job. Okay, so odds in favor, good job, of a vowel from elephant would be 3/5. Okay, I now want you to find how many ways are there to arrange the letters in the word elephant. This will be our last problem. Well, you can count. And I need to do this real quick, so give me a second. Ray, I don't think that that's right. Okay, hold on, guys. Grace, I think that that's right. Sorry, now I'm typing it in my calculator wrong. Grace, you're good. Alexis, try that again. Ben, you're good. Jackie, you're good. Good job, Joseph. Camila, you're good. Amberly, good. Good job. Greta, good. David, good. Shane, good. Neil, good. This row, you're all good. Good job. This row, Nathan, haven't fixed that. Good job. Gia, let me see. This row, you're all, great job. This row, good job. Thank you for being patient with me on that. So 8 factorial divided by 2 factorial, 20,160. Question for me on that. Okay, one thing I just want to make a comment on for your test Monday. Make sure that you are okay with multiplication counting principle. Odds in favor and odds against, good job. If you're arranging letters in a word, make sure you have parentheses around the denominator. Okay? Does anyone have any questions for me before you move about probability? Okay. Carefully, don't get up yet, but carefully put the boards, erasers back. You're not racing, guys. You're not racing. I will move the markers over here. Have a great weekend.
Benjamin, no running.
Hey, easy.